Hello, I'm Will Martin. I'm going to be giving you my video of a final demonstration for my ECE 491 course. First, I'm going to show you the hardware setup that I've been using for the last couple days. We've got 4 Microsoft HD Life cams and a 2x2 array. Okay, I'm going to show you one other thing that we have to consider when we're using these Microsoft HD Life cams. There's some sort of driver or firmware issue where MATLAB cannot reset the exposure, white balance, zoom, etc. values to manual unless you use the proprietary Microsoft LifeCam software to do so. So I'm just going to show you briefly how one goes about doing that. So once the program gets loaded up here, click on open this little sidebar. Go over to settings, select one of the cameras that you have. You're going to have to go through this with each camera. Once you've selected it, you're going to come down here to properties. You want to make sure that the checkbox for autofocus is clear, and similarly for white balance and exposure. Note that it doesn't actually matter what number you have in this box. Once you click this, once you click check mark from this box, you can set the exposure to be whatever you want in MATLAB. I'm also going to briefly show you one of the other issues I had with this camera. Right now I've got MATLAB's image acquisition tool open. I've got one of the cameras selected. I'm going to start the preview. And what you're going to see is that the brightness level when it very first starts rendering is not the same as the brightness level just a second or two later. There's the transition. So I had to add a 4-second delay in order to correct for that. And now that we have that prep work out of the way, I'm going to go ahead and show you my final results while I'm working on this project. I've just started my HDR GUI. You can see the prompt that gives you at the top here saying if you're experiencing camera alignment problems, run the script called camera.m. I've already done that and calibrated the cameras fairly well. Now, this is a very computationally expensive process, and that's why it's taking so long to run the setup. I also had problems with the cameras where they have some built-in hardware that tries to stabilize based on exposure settings. That was a difficulty I'm going to explain in my report. And part of the solution to that problem was setting each camera on a 4-second delay after turning it on from taking the picture. So that's another reason that this is taking so long. So now that the figure is drawn, we can look at our lowest exposure image here. You can see that there's only a little bit of information next to the light. You can kind of see through the windows over here. The lowest exposure setting, you can take out the colors on our color chart, see a little bit more information in the windows and broad outlines of the pupils. The third highest exposure setting is one that is pretty close to the actual color and light levels inside the building right now. You can see that we're starting to get a little bit washed out in this area. And then if you go to the highest exposure setting, you can see that we're completely washed out next to the light. You can just barely make out the frame of the window. Everything is washed out. Now if we compare each of these individual photos to the HDR combination, we can see that the color chart is coming through just fine. You can also make out this DVD maker box that I placed in the second cubicle. We are still pretty bad in the window area. You can kind of see through and get a little bit of detail, but you can't tell what it is. Also, we're not completely washed out next to the light. You can see a couple shadows. This shadow cast by a soda bottle that I placed there. And in the bottom two, in the lower two images for the exposures, the ceiling level is completely black, whereas in the HDR combination you can make out the grid lines of the ceiling tiles. Now just to show you that this is a video, I'm going to go stand in front of the cameras for a moment. And there you go. So that concludes my final video demonstration for ECE 491 for the custom high dynamic range implementation. In just a moment I'm going to record another video showing MATLAB's implementation for comparison purposes. Okay, I believe I'm recording now. This video is going to be to show you the built-in MATLAB implementation of high dynamic range image composition. You can see I've simply commented out the line that, oops, let me go back to that. Simply commented out the line that implements my custom implementation, and I've added a couple lines to have MATLAB do its own implementation. So, if we look at the figure here, you can see it looks pretty similar to what I showed you in the previous video, although in some ways it's superior. You can make out a lot more detail along the ceiling tiles over here. You can actually see what's through the window, but overall it's just a very ugly image. You've got lots of RGB pixelization in all of the soft areas. So as I mentioned in my midterm presentation, it's a simple trade-off. I would say technically the MATLAB implementation is superior because you can make out a lot more detail as far as actually the image. This color diagram doesn't come out as well, but you can make a lot more detail out here. You can actually see things that are in the shadowy areas. However, you get this really ugly pixelization. So that is the comparison, and that's the end of this video.